Algebra 3, Chapter 6, Section 7, Applications and Models. First of all, we're going to deal with applications involving right triangles. For these problems, the three angles of a right triangle are symbolized by the capital letters A, B, and C will be the right angle. The sides opposite the angles are symbolized by the letters lowercase a, b, and c, where c is the hypotenuse. You see an example here of how to set up one of these triangles. Remember that the side will always have the same letter as the angle that it's across from. Okay, so we're going to solve the right triangle shown. Now I've drawn one triangle and just labeled it with the letters. You need to fill in the letters with the information you're given. Use the Pythagorean theorem, the fact that the angles of a triangle total 180, and use the trig functions to find all the missing sides and angles. Pause the recording, give this a try, and resume to check your answer. For our first triangle, we know that angle A is 30 and side B is 3. So we find side A using the tangent, we find side C using the cosine, and we find angle B using the fact that the two acute angles in the right triangle must total 90, since the third angle is already 90. For our second triangle, we use the Pythagorean theorem to find the missing side measurement, and then we use our inverse functions to find the actual angle values themselves. So we'll use the inverse tangent and find that angle A is about 36.87 degrees, and then subtract that from 90 for B. As far as finding angle A or angle B, you can use any of the trig functions you choose. Now try this problem. Notice that our angle is given in degrees and minutes. Don't forget, you do have symbols for those in your calculator if you hit second apps. Pause the recording, give this a try, and resume to check your answer. By subtraction, and you can do that on your calculator as well, we find that B is 77 degrees 45 minutes. Then we used the sine to find side A, and we used the cosine to find side B. Using the sine and then the cosine rather than the Pythagorean theorem gives us a more accurate answer. Now find the altitude of this isosceles triangle. Remember, the altitude is going to go from the top angle. It's going to make a perpendicular line with side B, and that will form two right triangles. You know that theta is 45 degrees, and you know the length of B. Let me also remind you that that altitude will cut B in half. Pause the recording, give it a try, and resume to check your answer. Okay, so a little illustration here. We know that half of B is going to be 3. So actually I just put half of 6, but we know that's 3. And then we're going to use the tangent of the 45-degree angle to solve for h, and that gives us 3. A ladder that is 20 feet long leans against the side of a house. The angle of elevation of the ladder is 80 degrees. That would be the angle that the ladder makes with the ground. Find the height from the top of the ladder to the ground. Pause the recording, give this a try, resume to check your answer. Here's an illustration. We have an 80-degree angle of elevation, a 20-foot ladder, and we're solving for h. We need to know the opposite. We have the hypotenuse. That means we're going to use sine, and solving we get 19.7 feet. Now we have several angles here. A passenger in an airplane at an altitude of 10 kilometers sees two towns directly to the east of the plane. The angles of the depression to the towns are 28 degrees and 55 degrees. How far apart are the towns? Okay, what you're going to use here are the two right triangles, the fact that the plane is 10 kilometers above. Pause the recording, give this a try, and resume to check your answer. Okay, we're going to use the cotangent of 55. It's going to be d over 10, which is about 7 kilometers. And then the cotangent of 28 is d over 10, capital D, which is 18.8 kilometers. So the farther city is 18.8. If you're wondering about those angle measurements, remember that the angle of depression from the plane to the town is going to be the same as the angle of elevation from the town to the plane. So you can just transfer those angles to the lower part, the lower angles that are made by the same lines. The distance between the towns we get by subtracting the two results, and we get 11.8 kilometers. The tower that is 150 feet tall is placed on top of a mountain that is 1,200 feet above sea level. What is the angle of depression from the top of the tower to a cell phone user who is 5 horizontal miles away and 400 feet above sea level? Strongly suggest you make a triangle for this, make a picture. Pause the recording, give this a try, and resume to check your answer. Okay, here's our picture. Okay, we have the cell phone tower. Now, you've got the cell phone tower at 150 feet, and the mountain is 1,200 feet above sea level. That gives us a total of 1,350 feet above sea level to the top of the tower. However, the person is 400 feet above sea level, so subtracting those, we get the vertical distance of 950 feet. The person is 5 miles away. Notice the angle of depression is that upper angle, but it's going to be the same as the angle of elevation from the person's perspective. So, using that and using the inverse tangent, we get 2.06 degrees. Now you're holding one of the tethers attached to the top of a giant character balloon in a parade. Before the start of the parade, the balloon is upright and the bottom is floating about 20 feet off the ground, like you see here. You are standing 100 feet ahead of the balloon. Find an equation for the length L of the tether you're holding in terms of h being the height of the balloon from top to bottom. For this problem, what you need to do is you need to find the total height from the street level to the top of the balloon, and then you can subtract 20 from that. Then you're to find an equation for the angle of elevation theta from you to the top of the balloon, and then it says the angle of elevation to the top of the balloon is 35 degrees, find the height. Pause the recording, give each of these parts a try, and resume to check your answer. Okay, so for the first one, just going to use a little Pythagorean theorem. L squared is h plus 17 squared plus 100 squared. And we get this kind of bizarre formula, but that's all you need to do. For B, we take that the cosine of theta is 100 over L, or theta is the arc cosine of 100 over L. And then putting in the value they gave us for theta, L is 122.077. And then we can find h from there, putting that into the formula that we got in A, and find that the height of the balloon is 53.02 feet. A police department has set up a speed enforcement zone on a straight length of highway. A patrol car is parked parallel to the zone 200 feet from one end and 150 from the other. Find the length of the zone and the measures of angles A and B. And realize it's kind of one of those angle of elevation depression situations. Angle A is going to be the same measurement as the angle in the upper left corner of the triangle, and angle B will be the same as the measurement of the angle in the upper right corner of the triangle. Then for part B, find the minimum amount of time in seconds that it takes for a vehicle to pass through the zone without exceeding the posted speed limit of 35 miles per hour. Pause the recording, give these a try, and resume to check your answer. So for L, all we need to do is use the Pythagorean theorem and find that it is 250 feet. We will then use the tangent of angle A and get that that is 336.87 degrees, while angle B is 53.13 degrees. Since it is 250 feet from one end to the other, we need to convert that to miles. There are 5,280 feet in a mile, and then we need to consider that the speed limit is 35 miles per hour, so we want to be able to do that in 35 miles per hour, and they're converting that to 3,600 seconds. So when you put all that together, you get 4.87 seconds. Now we're going to find the diagonal of the cube and the diagonal of the base as shown in the figure. Now this is a cube, so we need to remember that that means all of the sides are the same. The diagonal of the base is going to be the hypotenuse of an equilateral right triangle, or a 45-45-90 degree triangle. So you're going to probably want to find some angles and some measurements here. Pause the recording, see if you can do this, and resume to check your answer. Okay, the diagonal of the base has a length of a squared plus a squared square root is square root of 2a. In other words, it's, like I said, it's an equilateral right triangle. The two sides are the same. You don't know what they are, but just write it as a general formula. And now we have that the tangent of theta is going to be a over the square root of 2a, which is the length of the diagonal, which is going to be 1 over the square root of 2. So theta is the arctangent of 1 over the square root of 2, and putting that in your calculator, you get 35.3 degrees. Okay, a little bit about bearings. Bearings are directions given in surveying and navigation. A bearing measures the acute angle that a path or line of sight makes with a fixed north-south line. For instance, a bearing of S 35 degrees E or south 35 degrees east, which is shown below on the left, means 35 degrees east of south. So in other words, start like you're going south, but then swing the angle 35 degrees east of that. And then you also see an example here of north 80 degrees west and north 45 degrees east. The first one tells you whether you're going to be going from the north line or the south line, and then the second tells you east or west. A ship leaves port at noon and has a bearing of south 29 degrees west. The ship sails at 20 knots. How many nautical miles south and west will it travel by 6 p.m.? At 6 p.m. it changes course to due west. Find the bearing and distance from the port of departure at 7 p.m. All right, not really used to working with bearings, so this might be a little difficult, but why don't you pause and see if you can at least get through part A. That one shouldn't be too bad. And try part B too if you can, and then resume and check your answer. Okay, so here's a little diagram of the situation. For part A, he's going 29 degrees, and it says it's going 20 knots, which is 20 nautical miles an hour. If he's leaving at noon, at 6 o'clock, he will have gone 6 hours. So 6 times 20 is 120. So he's gone 120 knots. Now, as far as south and west, now that's on the diagonal line. As far as south and west goes, we can use the cosine and sine to find the south component and the west component of that, as you see here. So he's gone 104.95 nautical miles south and 58.18 nautical miles west. As for the second question, you notice here that at 6 p.m., after he's gone 120, he changes course to due west, and he goes another hour, because the question is, where is he at 7 p.m.? So that's an additional 20 miles. So we know that at that point, B has extended to 78.18 miles, but A has stayed the same. So we're going to find the new angle by saying that the tangent of the angle is 78.18 over 104.95, which gives us an angle of 36.7 degrees. So he is at south, 36.7 degrees west, and then we can find the distance by using the Pythagorean theorem, and we get 130.9 nautical miles from port. The ship is 45 miles east and 30 miles south of port. The captain wants to sail directly to port. What bearing should he take? Pause the recording, give it a try, and resume to check your answer. All right, so he is 45 miles east and he is 30 miles south. Notice that what we did was we actually put the ship at 0, 0, and that would mean that the port would be 30 north and 45 west. So it seems a little backwards, but you actually want to take the bearing from the ship, so that needs to go at the 0, 0 point, or at the middle of your compass. Now, once we've put that in there, what we're looking for is theta. Well, inverse tangent should do it. So the tangent of theta is 45/30, which gives us an angle of 56.3 degrees. The bearing will be north, 56.31 degrees west. And harmonic motion. Because trig functions are periodic, it makes them ideal for describing the motion of a point on an object that vibrates, oscillates, rotates, or is moved by a wave motion. We describe this motion using period, amplitude, and frequency. Period, we already know it's the amount of time to complete one cycle. Amplitude is the maximum distance the object moves from rest. And then frequency is how many cycles go by per minute. A point that moves on a coordinate line is in simple harmonic motion when its distance d from the origin at time t is given either by d equals a sine omega t or d equals a sine omega cosine omega t, where a and omega are real numbers and omega is greater than 0. The motion has an amplitude of absolute value of a. It has a period of 2 pi over omega. That should sound familiar. The frequency, you just take the reciprocal. And you may wonder, well, how do I know if I'm supposed to use sine or cosine? And it honestly just depends on whether this particle starts from rest or starts from a point above or below rest. For a simple harmonic motion that satisfies this, okay, d equals 0 when t is 0. So in other words, this is starting at rest. A is 4 and period is 2 seconds. And remember, you need to use the period to find omega. The period is 2 pi over omega. Pause the recording, give this a try, and resume to check your answer. Because we're starting at rest, we're going to use sine because sine starts at 0, 0. The period is 2 pi over omega, which equals 2, which means omega must be pi. So d equals 4 sine pi t. A point on the end of a tuning fork is in simple harmonic motion described by d equals a sine omega t. Find omega given that the tuning fork for middle C has a frequency of 264 vibrations per second. Okay, pause the recording, give it a try, and resume to check your answer. If the frequency is 264 vibrations, and we know the frequency is omega over 2 pi, then we know that omega must be 2 pi times 264, or 528 pi. For the simple harmonic motion described by the function, find the maximum displacement, that's what's the farthest it goes from rest, the frequency, the value of d when t equals 5, and the least possible value of t for which d equals 0. Pause the recording, give this a try, and resume to check your answer. Okay, A, looks like I'm coming in backwards. There we go. A, the maximum displacement, is just the same thing as the amplitude, which is 9. The frequency is omega over 2 pi, which is 6 pi over 5 over 2 pi, and that simplifies to 3/5 cycle per second or per unit of time. And let's see, C, the value of d when t is 5, just put t in and solve, and we get 9. For part D, the least positive value for which d is 0, set it equal to 0, and solve. We get that the arc cosine of 0 is 6 pi 5 times t. The value of the angle when cosine is 0 is pi over 2. And then solving for t, we get 5/12.